Hey everyone, and welcome. Today, we're going to dive into a really cool testing technique that's all about one thing, following the journey of your data. Where does it start? Where does it end up? Let's get into data flow testing.
Think about it. We write code, we declare variables, we pass them all over the place. But do we ever really stop and trace the exact path a single piece of data takes from the moment it's born to the moment it's used?
Because if we don't, that's where the sneaky bugs love to hide. You know the ones. A variable gets a value it absolutely shouldn't, or it's used before it's even been properly defined. These are the kinds of frustrating little problems that can be a total nightmare to hunt down.
So, how do we catch these things before they cause chaos? Well, there's a technique built for this exact purpose, and it's called data flow testing.
Okay, so at its heart, this is a white box technique. What that really means is we're peeking inside the code, looking at its structure, not just what goes in and what comes out. And we're laser focused on the life cycle of our variables. It all boils down to two key events. When a variable is defined, that's when it gets a value, and when it's used, which is any time it's referenced.
So, that's the what. But how does this actually work in practice? How do you go from a bunch of code to actually understanding its data flow? Well, it's all about creating a visual roadmap.
Let's use a super simple piece of code as our guide. We read in two variables, x and y. Then, depending on which one's bigger, we give a value to a new variable, a, and finally, we print a. Seems simple enough, right? But believe it or not, there's a whole journey happening with our data just below the surface.
To actually see those paths, the first thing we do is map the code's logic. We create something called a control flow graph, or a CFG. Just think of it like a flow chart for your code. It shows every possible route the program could take. This graph is the absolute foundation for everything else we're about to do.
And this is where the magic happens. We take that graph and we start layering our data knowledge on top of it. We look at each variable and mark exactly where it's defined and where it's used. So, for example, the variable x gets defined at node 1, then it's used in the if statement at node 2, and maybe again in the calculation at node 3. We do the same for y and a. And just like that, the story of our data starts to become crystal clear.
So, if you zoom out, the whole process follows these pretty logical steps. First, you spot all your variables. Then you build that visual roadmap, the CFG. Next, you label all your defines and uses. And then, this is the crucial part, you analyze all the paths from every single definition to every single use. The final step? You create test cases specifically designed to make the program go down those exact paths.
Now, it's not a one-size-fits-all kind of deal. There are actually two main ways you can approach data flow testing: static and dynamic. They're both aiming for the same thing, but they go about it in completely different ways.
And this chart really nails the difference. Static testing is like being an architect reviewing a blueprint. You're analyzing the code and the control flow graph without ever running the program. You're looking for potential design flaws. Dynamic testing, on the other hand, is like taking the car for a test drive. You actually compile and run the code, watching the variables in real time to see if any weird issues pop up while it's actually running.
All right, let's get real. As powerful as this technique is, it's not a magic bullet, so it's super important to understand both its strengths and, its weaknesses.
The advantages are pretty awesome, honestly. This method is fantastic at catching those really specific, hard-to-find bugs, things like using a variable that never got a value in the first place, or defining a variable over and over again before it's ever used, which is a huge red flag for messy code. And the fact you can find some of these bugs without even running the program, that's a massive win.
But on the flip side, this isn't exactly a quick and easy process. Building the graphs, tracing every single one of those definition-to-use paths, it can be incredibly time-consuming, especially for big, complicated programs. And it's not really for beginners either. You need a pretty solid understanding of programming to do it right.
So after all that, the how, the what, the pros, the cons, what's the big takeaway here? Why should any serious tester or developer care about this?
Here it is. This is the most important thing to remember. Data flow testing is a huge shift in perspective. Most testing just asks, hey, does the code run without crashing? This technique asks a much, much deeper question. Does the story our data is telling actually make sense? It's like checking your code's narrative for plot holes, making sure every variable's journey is logical from start to finish. And hey, if you need a simple trick to remember the main ideas, just think of a duck. D is for define. Find where variables get their values. U is for use. Track where those values are referenced. C is for cover.
You've got to design tests to cover every single one of those paths, and K is for knowledge, remembering that to do this well, you got to know your stuff.
So I'll just leave you with this question to think about. The next time you're testing a project, ask yourself, are you just looking to see if the machine turns on, or are you actually following the story your data is trying to tell you? The answer might just change how you hunt for bugs forever.